So today we will discuss about kinetic theory of gas. What is kinetic theory of gas? Topic name is kinetic theory of gas. Now अगर कोई गैस तुम कंसीडर करते हो, सपोज एक गैस जार में गैस रखा हुआ है. This is a gas inside a container. Okay. Now the gas molecules of this gas are continuously moving from one point to other. They are continuously in movement. Okay. So we will study about the behavior of the gas. So initially कुछ assumptions लिया गया था कि gas molecules behave in this way. Okay. We call it postulates of kinetic theory. Postulates, or we call it assumptions, or we call it, spelling correct? TIONS. Okay. Assumptions, or we call it addiction. So these are the postulates of kinetic theory. Postulates means we assume that the gas molecules are like this, gases behave like this. Okay. What are these assumptions? क्या क्या postulate माना गया था? First, कि molecule of a gas are identical in all respect. Identical in all respect means they are solid sphere-like. Okay. Their shape are same. Their volume is same. Okay. And shape, size, volume, they are identical in all respects. So molecule of a gas are identical in all respect. Okay. But molecule of different gases are different. Okay. So gas molecules are, for a specific gas, the molecules are same, are alike, are same. Okay. For different gas molecules, the molecule is different. Okay. They are hard, perfectly elastic, solid sphere-like. Okay. And the volume of a molecule is negligible compared to the volume of the gas. Okay. The gas molecule occupy very negligible space compared to the volume of the gas. This was the first assumption. It was identical, gas molecules are identical in all respect. In all respect. For a specific gas. For different gases it will be different. Okay. Second, the gas molecules are in continuous, incessant random motion. They are continuously moving. Okay. So the molecules are not at rest. They are continuously moving. Okay. Hence, the gas molecule, because of their velocity, the gas possesses kinetic energy. So what is the reason for kinetic energy? Because of the continuous movement of the gas molecules. Okay. So, but these collisions, whenever the molecule collide with each other, because of this collision, it will not change the density of the gas. Suppose here collision taking place. So density will be more here. No, it is not like that. Okay. So in course of their motion, they collide with one another, but this collision will not change the molecular density. This collision will not make changes in the density. Okay. So the molecules of a gas are in continuous random motion. Are in random motion. They are moving in all possible direction with different velocities. Okay. Third, there is no intermolecular force of attraction between the gas molecule. There is no intermolecular force of attraction between the molecules of the gas. Okay. So gas do not possess any potential energy. There is no attraction, force of attraction between the molecule is not there. This was later on proved कि ये assumption wrong था, but initially जब ये assume किया गया था postulates में ये माना गया था, we assume that the force of attraction between the gas molecule is not there at all. Okay. So what is potential energy? Potential energy is the energy possessed because of the presence in their force field. Okay, in the presence of potential energy, the potential energy because of the force. Since there is no force of attraction, this was assumed that there is no force of attraction between the molecules. Therefore, it was assumed that gas do not possess any potential energy. So what is the total energy of the gas? The total energy of the gas is the kinetic energy because of the random motion. So intermolecular force of attraction is 0. No intermolecular force of attraction. Molecular force of attraction. Fourth, when the molecule moves from one point to other, the molecule may collide with one another. The molecule make collision. Okay, एक दूसरे से collide करता. So this time during which the two molecules remain in contact, okay, this is called time of collision. So this time is negligible compared to the time during which the molecule travels freely. जितना देर तक मॉलिक्यूल एक जगह से दूसरी जगह तक फ्रीली ट्रेवल करता, वो जो टाइम है, that time is much more than during which the molecules collide. Okay, so time of collision is negligible compared to the time during which the molecule travels freely. ठीक है? So the time of collision is negligible. Time of collision is much lesser than the time during which the molecules travel freely. Okay, travel freely. Now, suppose this molecule is moving from this point to this point, from this point to this point, from this point to this point, from this point to this point. Okay, these are called free path. What is free path? The distance between two successive collision. यहाँ से स्टार्ट किया, यहाँ एक collision हुआ, तो this is the distance, this is called free path. फिर यहाँ collision होने के बाद यहाँ एक collision हुआ, this distance is called free path. So the distance traveled between two successive collision is called free path. This is called free path. Now, free paths are not same for a particular molecule. See, if you see this distance, some are short, some are long. All the free paths are not same. For a particular molecule, the free paths are different. Okay, but if we take the average of the free paths, suppose this is D1, D2, D3, D4. If you take all the distances and divide it by the number of paths, then you will get mean free path, correct? So free path can be represented by lambda, then mean free path can be represented by lambda m. So what is mean free path? The average of all the free paths is called mean free path. So at a particular temperature, the average of all the free paths, that is the mean free path, is same. So free paths are not same, but mean free paths are same. Mean free paths of all the molecules are same, correct? Now, the pressure exerted by the gas at the wall of the container is because of what? Is because of the continuous bombardment of these molecules on the wall of the container. These molecules are colliding with the wall of the container, correct? So that is the reason the gas gives pressure to the wall of the container. Okay. So the pressure exerted by the gas is because of the continuous collision of molecules on the wall of the container, correct? And pressure exerted in all directions are same. That we will come to this. Suppose we have a tube like this. If pressure exerted along x-axis, pressure exerted along y-axis, pressure exerted along z-axis will be same. The pressure exerted in all the directions by the gas molecules are because of the collision with the wall of the container, and this pressure is uniform. All the direction the pressure will be same. Okay. Now, we are interested to find out, say, what is the relation between velocity of the gas molecules, or rather mean velocity of the gas molecules, and the pressure and density. What is the pressure exerted by a gas molecule? Okay. So let us consider a cube. It's a very 2 minutes calculation. We'll do this calculation. So suppose we have a cube like this. Okay. As a cube like this. So L is the length of each edge of the cube. Correct? This is length of each edge of the cube is L. So suppose this is origin. This edge is A, B, C, D, E, F, G, H. Okay. Let M is the mass of each molecule of the gas. N is number of molecules of the gas. Okay. L is the length of each edge. So therefore the L cube will be the volume of the gas inside this cube. Okay. So what will be the mass of the gas? M into L, that is mass of each molecule into number of molecules. This is the mass of the gas. Mass divided by volume will be the density of the gas. Okay. Achha. Now suppose there is a molecule having velocity c. C is the velocity. Now this molecule, suppose if we consider this edge, the three adjacent edge of this cube as x-axis, suppose this is x-axis, this we can consider as y-axis, this we consider as z-axis. Okay. So gas molecule can have a translational motion along x-axis or y-axis or z-axis. Okay. So suppose along x-axis, if suppose c is the velocity of the gas molecule. Okay. So c velocity will have three components. Along x-axis the component is u, suppose. Along y-axis the component is v, and along z-axis the component is w. Okay. So we know that from vector that c square will be, c square, the modulus will be u square plus v square plus w square. Correct? So along x-axis it is moving with a velocity u. Okay. Now suppose when the molecule, suppose this molecule is going to this place, collides with the wall and then comes back. So the molecule will cover a distance L and L, 2L distance, and will make a collision here. Correct? For one collision, the molecule will travel a distance L and comes back to L, to 2L distance. So what will be the time taken? If u is the velocity along x-axis, so what will be the time taken? 2L by u. Distance by velocity is the time taken. So 2L by u second, this molecule will make one collision. Correct? This will make one collision. Achha. So in 1 second, how many collision will happen? It is 1 by 2L by u, that is u by 2L collision will happen. Correct? This many collisions will happen in 1 second. Correct? Now we are interested in finding pressure. How pressure will come? Pressure can come from force. How force will come? Force can come from momentum. Rate of change of momentum is force. Okay. So we are interested in finding the rate of change of momentum. Okay. So suppose this molecule is colliding with this wall ABCD with a velocity u. So what is the initial momentum? M into u. Okay. So it is an elastic collision. If it collides with the wall with a velocity u, then it revert back with a velocity, with a speed u, only the direction changes. Okay. So when it is along x-axis, its momentum is mu, but when it is after collision, when it is coming back, then its momentum is minus mu. Correct? Because velocity direction is reversed. So what is the total change in momentum? mu था, mu से minus mu हो गया, तो total कितना change हुआ? Not zero. Total change is initial momentum minus final momentum. Correct? That is 2 mu. 2 mu is the total change in momentum of the molecule. Now, how many in 1 second what is the total change in momentum? एक बार collision होने से 2 mu momentum change हो जाएगा. Okay. Now, कितना collision होता है 1 सेकंड में? 2 u/2l collisions होता. तो एक बार अगर collision हुआ तो momentum कितना change हो गया? 2 mu. तो इतना बार collision होने से कितना change होगा momentum? That is 2 mu into number of collision u/2l. This is what? Number of collision into change in momentum per collision. This is what? Rate of change of momentum. एक सेकंड में momentum में कितना change होगा? Correct? So this is what m u square by l is the rate of change of momentum. This is called force. Okay? As per Newton's law, the rate of change of momentum is called force. Correct? So what is the force exerted by the molecule? M u square by L. So what is the pressure exerted by the molecule? What is pressure? Pressure is equal to force per area. Okay. So what is area? Area is L into L, L square. So what is pressure along x-axis? This is along x-axis. So the pressure along x-axis equal to m u square by L cube. Correct? Similarly, if we consider the motion of the molecule along y-axis, अगर मान लो मैं मानता हूँ कि molecule y-axis की तरफ कितना velocity से move कर रहा है? v velocity से move कर रहा है. अगर मैं y-axis की तरफ velocity लेता हूँ, तो y-axis की तरफ कितना pressure हो जाएगा? Py will be m into v square by L cube. Correct? अगर मैं z-axis की तरफ molecule का motion consider करता हूँ, तो pressure along z-axis कितना हो जाएगा? z-axis की तरफ component of velocity w है, तो m w square by L cube. Correct? Now, so these we got that the pressure along x-axis, pressure along y-axis, pressure along z-axis, we have derived all these things. Correct? Now, pressure exerted by the molecules in all directions are same. Okay? So if pressure along x-axis is P, pressure along y-axis is P, pressure along z-axis is also P. Correct? The pressure are same. So therefore, if we add these three, so you can take m by L cube common. It is summation of. Achha. If you want to take the total pressure exerted along x-axis, then this will be what? You have to take the m u square. No? You have to take the, this is pressure exerted by a particular molecule. But if you want to consider, if you want that the total pressure exerted by all the molecules because of their motion along x-axis, then what you have to do? You have to take the all the molecules, means summation of all the velocities. Similarly, take the sigma of all the pressures. So total pressure along x-axis is sigma of m u square by L cube. So let us take the constant out, m by L cube out. You are getting summation of u square plus summation of v square plus summation of w square. This is what? This is equal to PPP, means 3P. Correct? Now, so we can remove now this part. So what is, now we are interested in deriving the pressure. So it is m by L cube. U square means what? U1 square plus U2 square plus U3 square. So there are n number of molecules, so U1 square. Similarly, V square is what? V1 square plus V2 square plus V3 square plus up to nth molecules velocity along y-axis. W, summation of W square means W1 square, W2 square, W3 square up to Wn square. Correct? See, if C square is, U, V, W are the component along three mutually perpendicular axes. Okay? Similarly, U1 square, V1 square, W1 square will give these are the component of a particular molecule along XYZ axis. So if you add these three components, you will get, this is M by L cube, you will get C1 square, velocity of the first molecule. If C square is this, then C1 square, U2 square, V2 square, W2 square, this will give C2 square, second molecule's velocity. Similarly, this will be C3 square, so on and so forth, this will be Cn square. So it seems that जितने भी molecule है सबका velocity को हमने क्या किया, square कर दिया और add कर दिया. ऐसा कब होता है जब molecule का डायरेक्शन को नॉलिफाई करना चाहते हैं हम, डायरेक्शन का कि कुछ वेलोसिटी नेगेटिव एक्सिस के तरफ है, कुछ पॉजिटिव एक्सिस के तरफ है, तो जब हमको इस टाइप का कुछ डाटा पॉइंट्स को हम क्या करते हैं, स्क्वायर करके ऐड करते हैं, तो एक तरह से मीन जैसा हुआ. स्क्वायर क्यों किया जाता है, ताकि नेगेटिव भी है तो वो पॉजिटिव में कन्वर्ट हो जाए. ठीक है, तो मैं क्या करता हूँ, इसको n से डिवाइड करता हूँ. सपोज n क्या है, नंबर ऑफ मॉलिक्यूल्स, नंबर ऑफ वेलोसिटीज, करेक्ट. n एक नीचे लिखा तो n एक ऊपर लिखा. अच्छा, ये देखने में किस तरह का है, एक टाइप का मीन है, बट मीन ऑफ स्क्वायर्स. ओके, तो लेट अस रिप्रेजेंट इट बाय m1 by l cube. Let us write it c bar square. What is c bar square? C bar square is c1 square plus c2 square plus c3 square plus cn square by n, or c bar is what? Square root of c1 square, c2 square, c3 square, cn square by n. This is called root. All are added and divided by n, mean, and each term are squared. So this is called root mean square velocity. In one way, this represents the mean velocity of the gas molecules. Okay. So what is pressure? So pressure equal to Mn by L cube. L cube is volume. We can derive it as Mn is mass of the gas, L cube is volume of the gas, C bar square, or mass per volume is density. Acha, one thing I missed it out. This was 3p, correct? So this was 3p. So if p comes here, if we take p here, then 3 will go there. Okay. So now mass by volume, this will give the density rho C bar square. So what is the pressure exerted by a gas? The pressure exerted by a gas is equal to 1 by 3 rho into C bar square. What is rho? Rho is the mass per volume, density of the gas. Correct? So this is very, very important. Derivation is not important, but this expression is very important. Okay. Now the gas molecules normally do not obey all the postulates of kinetic theory. जितने भी assumptions हम लोग लिया था ना, सब के सब नहीं मानता है. जो gas molecules normal temperature pressure NTP या बोलो standard temperature pressure में kinetic theory का सारे postulates को, सारे assumptions को मानता है, उसको क्या कहा जाता है? Perfect gas. What is a perfect gas? The gas molecules which obey all the postulates of kinetic theory at normal temperature and pressure, then they are called perfect gas. If the gas at normal temperature and pressure, they are not obeying this postulate, hence since these gas molecules do not obey all the postulates, they are called, we cannot call it imperfect gas, we call it ideal gas. So what is an ideal gas? The gas molecules at normal temperature and pressure called ideal gas. Why? Because they are not perfect at normal temperature pressure, correct? So what is the condition? At what condition a normal gas will obey the postulate? If the pressure is very low, if the pressure is low and temperature is high, if the pressure is low and temperature is high, then all the molecules of gas obeys the postulates of kinetic theory, correct? So the condition for an ideal gas to be perfect क्या होना चाहिए? प्रेशर कम होना चाहिए, टेम्परेचर ज्यादा होना चाहिए, करेक्ट? नाउ we will see what is temperature in terms of kinetic theory. This is called kinetic interpretation of temperature. Kinetic interpretation of temperature. Temperature क्या है? What is kinetic interpretation? Kinetic interpretation of temperature. Okay, let us see this equation. P equal to 1 by 3, rho is what? Mass per density, Mn by V, C bar square. Okay, so we say PV equal to Mn by 3 C bar square. This is from the kinetic theory of gas. Okay, but from the gas equation we know that PV is equal to nRT. N is what? Number of moles. Okay, so number of moles is what? Mass of the gas divided by molecular weight of the gas, that is called the number of moles. So PV equal to N, R is universal gas constant, T is temperature in absolute scale. Okay, this is our perfect gas equation. Okay, so as per the gas equation we know that P, pressure into volume, is this much. As per kinetic theory we know that pressure into volume is this much. So these two must be identical from equation 1 and 2, correct? So Mn C bar square by 3 should be equal to Mn by M RT, correct? Okay, so we can write Mn cancel out. Let us represent this as equation number 3. So in this equation, if Mn cancel out, then C bar is how much? C bar equal to root over 3R by N into T, or C bar is, R is universal gas constant, N is molecular weight of the gas. So for a definite gas, C bar is proportional to temperature. This is the kinetic interpretation, means the root mean square velocity of the gas molecule is proportional to the absolute temperature, square root of absolute temperature. Okay, now suppose if we increase the temperature, then the root mean square velocity of gas molecules will increase, correct? So this is called kinetic interpretation of temperature. Now we can derive what is the mean kinetic energy of the molecule. See, from this equation, if we consider this equation, Mn C bar square is equal to Mn this. Okay, so what we can find out? Mn C bar square by 3 equal to Mn by M. M is mass of each molecule, number of molecule, by molecular weight into R into T. Okay, now molecular weight of the gas is nothing but the mass of each molecule into the Avogadro's number. What is Avogadro's number? The number of gas molecules contained in 1 mole, 6.023 into 10 to the power 23. Okay, now this is universal gas constant, this is Avogadro's number. This ratio, this R by N, this is called Boltzmann constant. Sometimes we write as Kb or K, anything you can write. So this is another constant. Okay, so Mn cancel out, Nn cancel out. Okay, so this equation looks like kinetic energy, half mv square sort of thing. So let us take m c bar square here, let us take 3 here, 3 R by N. R by N is what? The Boltzmann constant into T. So if we multiply both sides by 1 by 2, then what is happening? Half M is what? Mass of each molecule of the gas into C bar square is how much? 3 by 2 kT. This is called the mean kinetic energy of the gas molecule. Okay, so what is mean kinetic energy? Mean kinetic energy is equal to 3 by 2 kT. Now if T is 0, means absolute 0, minus 273 degrees Celsius. What will happen? This term will become 0. If right hand side is 0, then mean kinetic energy is 0. So absolute 0 can be defined as the temperature when the mean kinetic energy of the gas molecule becomes 0. Okay. So if T is increasing, the velocity increases. When T becomes 0, the velocity becomes 0. If the velocity is 0, then the kinetic energy vanishes. Hence, we cannot imagine even temperature less than minus 273. एब्सोल्यूट 0 से नीचे का टेम्परेचर हो ही नहीं सकता. क्यों? अगर नीचे होगा तो काइनेटिक एनर्जी नेगेटिव हो जाएगा. नेगेटिव एनर्जी वी कैन नॉट इमेजिन इवन. करेक्ट. सो एब्सोल्यूट टेम्परेचर, दिस इज द काइनेटिक इंटरप्रिटेशन कि at absolute 0 the mean kinetic energy of the gas molecule vanishes. Correct. So now we got very important equation that C bar is 3RT by M. Okay. So C bar is 3R by M into T. Correct. So can we have our gas laws like Boyle's law, Charles' law, Avogadro's law, Graham's law, Donel's law. So different laws, all these laws can be derived from this kinetic theory of gas. Let us see Boyle's law. Boyle's law. What is Boyle's law? At constant temperature, when the temperature is constant, then there is a definite relation between pressure and volume. If you increase the pressure, the volume will decrease. Okay. So pressure, volume is inversely proportional to the pressure applied. Okay. Or if we take this constant, then PV equal to constant at when T is constant, at constant temperature. If T is constant, then pressure and volume are inversely related. Correct? They are inversely related. Now we have to prove this Boyle's law using the kinetic interpretation, using this pressure exerted by a gas. How to prove it? See, this is our pressure exerted equation. 1 by 3, rho is density, density is mass per volume, C bar square. Correct? So you take V here, so this becomes PV is equal to 1 by 3 Mn. And what is C bar square? C bar square is 3Rm by T. Correct? So we can put C bar square as 3R by M into T. So here you see this is mass of molecule, each molecule, this is number of molecules, this is universal gas constant, this is molecular weight, all the right hand side is constant except T. If you keep T constant, then the right hand side, entire expression of right hand side is constant. Correct? So if temperature is constant, then P into V equal to constant. This is what is called Boyle's law. So we can prove Boyle's law using the pressure exerted by the gas. Now let us say what is Charles' law. What is Charles' law? Charles' law operates at constant pressure. Okay. So at constant pressure, if the pressure is constant, then the volume of the gas is proportional to the temperature. If you increase the temperature, the volume will increase. Okay. So we say that volume divided by temperature equal to constant. When the pressure is constant, when P is constant. If you do not change P, if you do not change pressure, then on increasing temperature, the volume of the gas will increase. Correct? So we have to prove this. Volume divided by temperature is constant. How to prove it? Let us start from here. Pressure equal to 1 by 3. Density is what? M into N by mass divided by volume, C bar square. Correct? Pressure is constant. Let us take V here. So this is Mn by 3 into P. And what is C bar square? C bar square is this 3R by M. This is a square C bar. So if you square it, square root will vanish. So C bar square is 3R by M into T. Correct? So, sorry, V we have taken here. P is here. Okay. So now this 3 cancel out. If pressure is constant, rest of this, all the term like mass of each molecule, number of molecule, universal gas constant, molecular weight of the gas, everything is constant. If P is constant, then entire thing is constant except T. So if P is constant, what is the only variable thing? Temperature. We can change the temperature. Rest of the things are constant. So in place of equal sign and constant, we can write a proportionality sign. This is what is called Charles law. So we can deduce Charles law using the pressure exerted by the gas equation. Okay. Now let us say another law, say Avogadro's law. What is Avogadro's law? Avogadro's law says that equal volume of all gases at same temperature and pressure contains equal number of molecules. If you take gas A in a gas jar having temperature T, pressure P, volume V, another gas you take having, this is a different gas, this is gas A, this is gas B, okay, volume V, temperature T, pressure P. If the volume, temperature and pressure are same, then the number of molecules in gas A will be same as the number of molecule in gas B. This is called Avogadro's law. Now, in Avogadro's law, if we want to prove it, suppose let us consider two gases. Okay. For the first gas, the pressure exerted by the gas is P1 equal to M1, mass of each molecule, N1 by 3 into V1 into C1 bar square. Okay. Okay. So P1 V1 equal to N1 by 3 C1 bar square. Let it be like this. Let us consider another gas. Okay. Another gas whose pressure is P2, volume is V2, mass of each molecule is M2, number of molecules is M2 by 3 into C2 bar square. The velocity is different. Okay. Okay. Now, for the first gas, now if P1 is equal to P2, V1 equal to V2, then what will happen? Because Avogadro says that at the same temperature, pressure, equal volume of all gases. Equal pressure is same, volume is same. Okay. So this should be equal to this. M1, N1, so P1, V1 equal to P2, V2, no? If P1 equal to P2, V1 equal to V2, then P1, V1 will be equal to P2, V2, correct? So in place of P1, V1, you can write M1, N1, C1 bar square, okay, by 3 equal to, for this you can write M2, N2 by 3 C2 bar square, correct? Now, what is this mean kinetic energy? You have seen M1, N1 half M1 C1 bar square equal to 3 by 2 KT1, correct? And for the second gas, the mean kinetic energy will be M2 C2 bar square equal to 3 by 2 KT2. Okay, this is the mean kinetic energy of the first molecule, this is the mean kinetic energy of the second molecule. Now, if temperature are also same, then these two should be same, correct? Half M1 C1 bar square equal to half M2 C2 bar square if T1 equal to T2. If T1 equal to T2, Avogadro exactly says the same thing. Same pressure, same volume, same temperature. Then we have to show that the number of molecules will also be same. Okay. So these two are same. Let us divide both sides by this side by m1 c1 bar square by 2, 2 to cancel out. Okay, so divide both sides. In this side you write m1 c1 bar square, in this side you write m2 c2 bar square, because they are same. It is the same thing, m1 c1 bar square and m2 c2 bar square are same. So m2 c2 bar square cancel out. With this m1 c1 bar square cancel out, 3 cancel out. So what is left? n1 equal to n2. So it says, what is n1? The number of molecules of the gas in the first gas. Okay. What is n2? The number of molecules in the second gas. So we have now proved that if pressure, volume, temperature are same, then number of molecules are also same. Okay, so we have proved Avogadro's law. Now let us see Graham's law of diffusion. This is another law. Graham's law of diffusion. Diffusion means the rate at which the gas molecules diffuses. Okay, जिस रेट से गैस मॉलिक्यूल फैलता है. ओके, जैसे तुम परफ्यूम रख दोगे तो परफ्यूम का क्या है कि उसका डेंसिटी बहुत ही कम होता. तो ग्राम ने एक लॉ दिया था जिसमें उसने कहा कि जो रेट ऑफ डिफ्यूजन है दैट इज इनवर्सली प्रोपोर्शनल टू द डेंसिटी, जिसका डेंसिटी स्क्वायर रूट ऑफ डेंसिटी. ओके, सो इफ द डेंसिटी इज मोर then the rate of diffusion will be less. So you have to prove Graham's law of diffusion. Okay, let us see. So we have our pressure exerted by the gas equation 1 by 3. This is rho. Rho means density. C bar square. Correct. So we can take P equal to 1 by 3 rho C bar square. So C bar square is equal to 3 times pressure divided by density. Correct? Okay. So C bar is equal to what? Is root over 3 P by density. Correct? So what is density? Density is mass per volume. Mass of the gas divided by volume of the gas. Correct? So invariably we are saying that the root mean square velocity of the gas molecule is inversely proportional to the square root of density. Okay. So in this way we say that the rate of diffusion means if the speed is less then the diffusion rate will be less, so they are inversely related. The root mean square velocity is inversely proportional to the square root of density of the gas. Okay. See, we did this kinetic theory of gas. Okay, these are the assumptions of kinetic theory. So the mean free paths of all the molecules of a gas are same. Then this derivation is not important, but throughout your 11th and 12th chapter, you have to use this equation, P equal to 1 by 3 rho C bar square. If you know how it is derived, because it is, we have calculated the force, momentum, then rate of change of momentum, then from the rate of change of momentum we got the force, then force by area is equal to pressure. Okay. Pressures are same in all the direction. Okay, so all these small concepts are there in deriving this equation. That is why I have taken too much interest in deriving this. Otherwise, if you are solving your state board or your ICSE CBSE board question paper, then if deduction is required, then you can practice it. Else, for your own concept clear, you should know how this formula is derived. So then we derive this Boyle's law from the kinetic theory of gas. Okay, then what is kinetic interpretation of temperature, what is absolute temperature, what is Avogadro's hypothesis, this also we proved. Okay, so this completes our kinetic theory of gas except these two parts. Okay, we will discuss in detail when we will solve the numericals. So we will come up with the second video with advanced topics of kinetic theory of gases. Thank you very much.